Ladies and gentlemen, please welcome to the stage Georg Plaswilm.
Good morning and welcome to NIDays 2014. It is an exciting time to be an engineer, and we are proud at National Instruments of the accomplishments you and I have achieved together. And we're excited at what challenges you and I will solve in the coming years. Now, the technology trends like the Internet of Things, big data, and also the wireless innovation represent business opportunities for all of us. Today, you'll have the chance to discuss these technology trends with peers through 25 technical sessions, 2 expert-led keynotes, and more than 30 interactive demonstrations on the exhibition floor. Now, this NIDay will prepare you with the opportunity to address your challenges you face today and to seize the opportunities of the future. So we are very excited to have you here, and I think let's get started. And with that, I would welcome on stage from National Instruments Corporate, Eric Starkloff.
Okay, well, good morning and welcome once again to NIDays. It is really, truly an incredible time that we all live in. I mean, think about it. Really, the significant proportion of the major innovations in the entire history of human existence have taken place or will take place in most of our lifetimes. And as engineers, we get the opportunity not only to have a front row seat to this innovation, but we actually are creating it. And as Georg mentioned, one of the big trends that's happening in the world around us that many of us are involved in now is this trend of convergence of a set of technologies around processing and sensing and communication and software. And this trend goes by lots of different names. You've heard it maybe called the programmable world. You've heard it maybe called cyber-physical systems. The Germans call it Industry 4.0. And of course, it's called the Internet of Things. And this isn't just a buzzword. The Internet of Things is real. I'll show you a picture just to illustrate that. Now, I'm from Austin, Texas. And in addition to all the high-tech companies in Austin, Texas, we're known for 2 other things: barbecue and live music. And here's a picture of a concert in Austin just 5 years ago. Okay? Here's the same concert today. Look how much things have changed, right? It's pretty profound. All these people, they're not just taking pictures and videos of the concert. Of course, they're sharing them. And they're loading tremendously the wireless network around them as they do that. Now, honestly, I have a little mixed feelings about this. Sometimes I wish we'd just watch the concert. You know, but nowadays it's not, you haven't really experienced it until you've posted it on Facebook or Twitter, right? And so that's not going to change. And really, I believe this is just the tip of the iceberg that we've seen. This connectivity is not just going to happen more and more in the consumer world, but as I'll talk about, these same technology trends are going to impact the industries that we all work within. Now, the Internet of Things itself isn't really a technology. It's a convergence of key technologies. And I want to walk through those and talk about how they are impacting the applications we serve. The first of those technologies is really, a little order issue there. First of these technologies is Moore's Law, right? Gordon Moore from Intel back in the mid-1960s postulated that the density of transistors on an integrated circuit would double approximately every 2 years. And this is largely held true up until today. And this is what has enabled us to put really powerful processing in basically everything, every device. And subsequently and consequently, we've been able to put more and more powerful software running on all of these devices that we design and that are all around us. The second key technology is networking and connectivity. And this is based on kind of another law, Metcalfe's law. This is named after Robert Metcalfe, who actually, as it turns out now, works at the University of Texas at Austin. And Metcalfe's law basically says that the value of a network is proportional to the square of the number of users, number of connected users. Okay, and this is what's given rise to the incredible growth of things like the internet. As more and more users get connected, it becomes more and more valuable at an exponential rate. There are now 3 billion people in the world connected to the internet. Most of those are on a mobile device. That's a huge number, and it's been incredibly valuable to all of us in the world. Now, over the next few years, though, it's not just going to be about more people connecting to the network. It's going to be about more devices and machines. It's estimated that in the next 6 years, there'll be 50 billion devices connected online. I mean, think about that. There'll be an order of magnitude more things connected to our networks than there are people. And the value that will come from that will be truly extraordinary. The third key area then that brings us to is wireless connectivity and wireless technology, because most of these devices ultimately will be connected wirelessly. And this will put incredible demands on our future networks. We talk a lot about the need for increasing bandwidth and capacity, but it also is going to drive needs for reduced latency, especially as we put more and more devices and machines on these networks. You know, an example is a lot of work's going on in connected cars and vehicle-to-vehicle communication for applications like collision avoidance. That's a very, latency is obviously a very, very important element of that kind of application. It doesn't do you much good to automatically apply the brakes a second too late, right? So these devices require very, very low latency. Researchers today, many of you might be working in some of these fields, are working on next-generation wireless standards like 5G that are promising 1,000-fold increase in capacity. And they're also looking to address these very tight latency requirements for real-time machine-to-machine networks. And the final trend is the ubiquitous sensing, the explosion of sensing technology that's enabling these systems to not just be networked computing nodes disconnected from the real world, but is enabling them to sense and monitor and control the world around them. You know, just the example I use always is think of all the sensors that are just in the smartphone that's in your pocket. Chances are your smartphone has 8 or 9 sensors on it, right? Probably has touch, camera, microphone, motion, gyroscope, temperature. The new ones have barometric pressure, humidity, and this is going to keep going on and on. So this trend of ubiquitous sensing and lowering the cost of data acquisition and control is really allowing us to connect these systems with the real world and effectively turn the world around us into one large programmable system. And so taken together, these 4 areas converge to create this trend we call the Internet of Things. I like to think of this as a revolution that's been kind of a few decades in the making. But it's here, and we're seeing an explosion of ability to take care of, or to take advantage, rather, of these applications. Now, the areas you hear about a lot that are talked about in sort of consumer media are around all these consumer devices, right? Smart phones, smart homes, wearables. And certainly these are key trends in the industry, and many of you are working in these areas and perhaps testing these kind of devices. And this trend of increasing software and programmability creates challenges for test and measurement, for example. NI's platform is used to test all of these kind of consumer Internet of Things devices, and I believe that our software-based approach is ideally suited to the increased software centricity of these kind of devices. On the other side, though, these same trends of sensing and networking, programmability and software are also being used in industrial applications and what we call the industrial Internet of Things. These are things like a smart factory, smart machines, smart grid, smart electrical grid, and smart car. And in these areas, there is tremendous opportunity for new applications and for disruption in areas that all of us work in most likely every day. It also gives us a huge opportunity in these industrial applications to have a big impact, a major impact in the world around us. These are huge, impactful applications like more intelligent monitoring of cargo, outfitting intelligence in freight liners and containers to be able to control better their routes, monitor the cargo, save on fuel, for example. These are areas like putting more intelligence and embedded technology in alternative energy generation like a wind turbine to improve its performance, monitor and improve its performance, and to connect up this sort of dynamic power generation source to the grid in a more intelligent way. Now, it's interesting, just on the flight over, I flew over a day before yesterday, and literally on the plane, I was reading this month's edition of the Harvard Business Review. The November issue, the cover story, ironically enough, is the Internet of Everything. And this article actually talks about the areas where they see major business disruption and business impact and opportunity. And they highlight the 5 areas that I show there. And you can see that many of these are in that kind of industrial Internet of Things. They actually talk about the industrial internet. They talk about connected cars and connected cities, smart grid applications. And so again, these are really the areas that all of us likely work within. And this article was really about the major changes that this is going to create for technology and business opportunities in each one of these industries. Now, there's another term I mentioned, and you may or may not have heard it. It gets talked about a little less than, let's say, something like the Internet of Things, and that's cyber-physical systems. And honestly, this is a bit more of a technically rigorous description of the same trend. This is used commonly in academia and research institutions, and it really puts a finer point and description on the major components that are driving this technological innovation. The 3 C's of cyber-physical systems are computation, communication, and control. And this is an area where National Instruments is working with lead researchers here in the UK and around the world on driving forward the theory of cyber-physical systems as well as the applications that can fundamentally take advantage of these same technology trends to improve the world around us. So that leads us to how can we, you and NI together, take advantage of these trends and use this as an opportunity in our own businesses. And fundamentally, I believe one of the keys is taking advantage of a platform-based approach. A platform like National Instruments has, or like the consumer example of a smartphone like the Apple iPhone, really gives users the ability to create applications on top of the underlying processing and I/O and software capability that that platform delivers. And as the world gets more complex and more connected, you're either going to be building a platform or building on top of a platform to remain competitive. Now, NI invests tremendously and will continue to invest in the underlying technology platform for you to build on top of. And this morning, our team is going to be showing you, and they're very excited to do so, to show you the latest innovations and technology and products that are part of this platform. And I really look forward to meeting with many of you and talking about the opportunities we have together to pair up our investments and your own domain knowledge to build on top of this platform to address these incredible opportunities in areas like the Internet of Things and in applications that we haven't even imagined yet. And so without further ado, I want to bring the team up and start diving in and showing you some of this technology in action. And so with that, let me introduce, and please join me in welcoming to the stage from NI UK, John McLaughlin.